Hi, I'm Daniel Haikal.
Hello, I am Izzy.
Hi, I'm Adriana.
I am Hafi.
Hi, I'm Fahmi. Our group will present the DAC in the application of audio-based device. So let's get started. So first we will go to abstract. Main objectives are to describe the functionality and application of a DAC, digital to analog converter, which is in this case study there will be four main things that will include it, which is the first one is details of the circuit diagram, DAC types. Number three is the calculations involved, and the last one is steps involving DAC conversion. Introduction and background. Actually, what is DAC? DAC is widely used in audio device application that convert the digital audio signals to an analog signal. Because the digital audio signals, we as a human can understand the digital signals. Better DAC will give higher quality of conversion, which of course will give a better sound. So why DAC is very important in audio devices? Basically, for a long time ago, the sound was collected and stored as analog signals by microphones that is then pressed into the grooves, and the needle on the turntable will felt those grooves that form an electrical signal, send these signals to the preamplifier to the speakers. But nowadays, people will record his voice, which will pick as an analog signal that will convert it to digital by ADC, analog to digital converter. And from that, DAC will decode a digital signal to convert to analog signal that make us can hear what the music or the audio is about. That's why DAC is very important, because without the DAC, we can appreciate the digital audio portability and simplicity.
I will continue with the methodology of DAC. So first, how DAC works. The DAC application in audio device works through the conversion of audio output from a source into the converter. The audio is sent to the DAC in digital form together with binary values, a series of zeros and ones in a sequence. Then the DAC proceeds to convert the digital signals into continuous analog signals. And lastly, the users will hear the output, which is the audio, via headphone or other listening devices because it connected to the DAC, and this will enable the user to hear the audio. And the figure shows working principles of DAC. So next, during the conversion of signals from digital to analog, a tiny computer takes snapshots, which are the samples, of the audio signal every few microseconds, and the samples are translated to voltage levels accordingly. The computer will measure the voltage levels and assigns number from the binary code for each samples, which are ones and zeros. The digital data is converted to analog sound waves, and the DAC will convert the sample back to the voltage levels. The audio will exit the DAC and goes to any device that connected to DAC's output jack. And as you can see at the right of the slide, the figure shows an example of samples data and the output signal. So next is the circuit diagram. The figure shows the example of circuit diagram in audio amplifier circuit, which the input of the amplifier is the most important input on the amplifier or compact system is called AUX or auxiliary. And as you can see at the right figure, there is TDA1510, which is a hi-fi audio amplifier which can output 50 watt of audio power.
So moving on, digital to analog conversion can be achieved using a number of different methods, but the two most common ones are using the binary weighted resistors and the R to R ladder network types of DAC. So for the binary weighted resistors, it consisted of n number of switches with one for every bit applied to the input. Next, the reference voltage generally in DAC in general is generated internally or provided externally to decide the maximum output voltage of the DAC. Next, uh, this circuit utilizes an op-amp, which in this case it is the inverting summing amplifier, and the weighted resistors used here are kept as multiples of 2. So for example, if V1 uses a 1 kilo ohm resistor, so the next input V2 would use a 2 kilo ohm resistor, and this will end up resulting in an output signal of 180-degree phase shift. Moving on to the next type, we have the R2R ladder network. So in this network, it uses fewer variations of resistor values where there is no need for a large range of precision resistor. So The resistors here are connected in parallel and in series, which it only uses two resistor values with the base value R and the other is 2R. So the resistors here act as voltage dividers along with the entire network with the output voltage dependent on the input voltages. And similarly, this circuit also utilizes an operational amplifier, and there is still negative feedback resistor connected to it. So to recap, both DAC conversion methods produce a weighted sum output with the weight set by the resistor values used in the R2R ladder network contributes to a different weighted amount to the signal's output. And to evaluate the efficiency of each circuit, a number of factors should be taken into account, but in considering the resistor values used in both circuits, the use of the R2R ladder network is said to be more practical in converting digital to analog signals, which applies in the application of audio device.
Next, I will explain about the results. First of all, we have DAC device output. So DAC will capture and store a binary number, convert it into a physical digital signal, and holds that value for a specified sample period to process and produce the analog signal output. Firstly, we have digital DAC will receive a digital signal input in the form of a clustered waveform. And then the DAC will convert it into an analog output signal in the form of a sharp steps waveform. And then the low pass filter will be utilized to refine the sharp steps to produce a more precise reconstruction analog wave output signal. Next, we have block diagram of MP3 player. MP3 is an example of an audio signal device that contains AD7224 tag gates. Data signal will be encoded and decoded by a digital signal processor. First, the audio signal data will be received from the sound, microphone, or radio FM by the ADC, and the ADC will convert the analog data to digital data to be processed by the digital signal processor. And DSP will encode the data and send the data to the flash memory through the microcontroller unit. After the data stored into flash memory, it will be returned the data to microcontroller unit to decode the data. And digital signal processor will decode the audio data and send it to the AD7224 DAC to convert it back into the analog signal so that it can be heard by the user through the headphone or speaker. After that, we have AD7224 DAC block diagram that used in the MP3 player. AD7224 is a DAC that produces a voltage output with a precision of 8-bit binary. It is equipped with an output amplifier and double buffer interface logic on a monolithic CMOS chip. It contains 18 pins, as you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the rest of 8 pins come from the input of 8-bit data from the most significant bit to the least significant bit. Lastly, we have binary number. AD7224 DAC facilitates 8-bit accuracy so that only 8-bit binary number can be received through it. Hence, it can represent a maximum input of 256 with the range of 0 to 255. The table below shows the 8-bit binary number from its decimal with the representation from the 0 to 8 and the maximum value of 255.
Hi and hello everyone. Now we move to the discussion part. As we know, there are two types of DAC, which is binary weight DAC and two-hour ladder DAC. As we know, this DAC consists of an ideal op-amp. So when we use ideal op-amp, there are two rules, which is input current will be 0 and input impedance is infinity. So for the further details, I will give some example of calculation. Let's say the code is 1011, we will assume Vref is 5 volt, we need to calculate the output voltage. So this is the general formula Vout, and we can insert all the value into the formula and we can get the answer. As you can see, the answer is in negative value. Why it is negative? This is because this type of the AC consists of inverting amplifier. From the calculation above, the value of BO is taken from the least significant bit and B3 is the most significant bit. From the calculation, we can conclude that binary input 1011 can be converted into negative 6.875 volt using binary weighted DAC. So what are the advantages of using this DAC? First, it is simplest construction rather than other type of DAC and provides fast conversion. So there are also disadvantages using this type of DAC, which is it requires a big range of resistor of high precision for low resistor, making it impractical and insufficient for converters with more than just a few bits of resolution. Now, we move to the second type of DAC, which is R2R ladder. For a clearer view, let's try some calculation related to the R to R ladder. Let's say the input code is 1011. We assume that the feedback resistor is equal to R. So this is the diagram and this is the formula. We insert the value into the formula and we get the 6875 volt. Now, what are advantage of using this R to R ladder? The resistor that used is only 2 and the position of the resistor is no need. It is cheap and affordable. Number of bits can be expanded by adding more sections of same R to R value. There are also some limitations, which is it has slower conversion rate compared to binary with DAC.
Conclusion. Actually, DAC is widely used in audio device applications. So in this case study, we are able to describe the functionality and application of DAC. Two types that is very common use: binary weighted resistor and R2R ladder. R2R ladder is a cheap and easy to manufacture, but is less conversion rate compared to binary weighted resistor that is much more expensive and higher conversion rate. That's it for us. Thank you.